Assalamualaikum warahmatullahi ta'ala wabarakatuh. So this video is a complimentary video to MCTE 2311 Signal and System Analysis. In this video, I will show you the solution to a sample problem that I give in the video on classification of signals. So if you refer back to that video, at the end of the slide, I give you a sample problem where you have to find the period, okay, the fundamental period and the fundamental cyclic frequency of three different signals. Okay, so this is the first question. But if you look at the question here, okay, you actually can write like this, okay. You make this equation equal, right, okay, the general form of the sine function, which is 2 pi t, okay. So you can make this part, okay, actually equal, so you can write 2 pi f naught equals to 400 pi. Okay, so you rearrange this equation, you will get 400 pi over 2 pi. So this part cancel each other, and here it becomes 200. Okay, so the fundamental cyclic frequency for this equation is 200 Hertz. Now we know that the period, okay, fundamental period is actually the reciprocal of the fundamental frequency. Okay, so in this case, the time period is equals to 1 over 200 seconds. Now let's look at the second question. Okay, so this is the second question, okay, where you can see g of t here is actually the result of summation of the sine wave. Let's call it g1 of t, and the cosine wave, let's call it g2 of t. Okay, now similar to the previous one, you have to find frequency and period. Okay, now let's look at this problem, okay, one at a time. So g1 of t is 10 sine 1 over 12 pi t. Okay, so similar to before, we write down the general form of the sine function, which is a sine 2 pi FOT. Okay, and again we can make this part equal. Okay, so you will have 2 pi FO equals to 1 over 12 pi. So you have FO 1 over 12 pi multiplied with 2 pi. Okay, so you will have let's call this FO1, yeah, FO1, because this is the first signal. FO1 equals to 1 over 6 Hertz. And for this one, you will get TO1 equals to 6 seconds. Okay. On the second signal, G2 of t is 4 cos 1 over 18 pi t. Okay, again you can write the general form of the cosine function as a cos 2 pi f naught t. Okay, and you can make this part equal. So you will have 2 pi f naught equals to 1 over 18 pi. Okay, so you will have 1 over 18 pi multiply with 2 pi. So you will have FO equals to 1 over 9 hertz, which means sorry, let's call this FO2. Okay, because this is the second signal. Okay, so you will have TO2 equals to 9 seconds. Okay, now you have two fundamental periods. Okay, this one and this one. Now, in order for you to find T, okay, TO, which is the fundamental period of G of t, okay, you have to apply a mathematical theory known as least common multiply, okay, or what they known as LCM. Okay, this is just a mathematical theory. Okay, we will show you how to apply this LCM. Okay, so now we have two numbers. Yeah, so here is LCM, and we have two numbers, which is TO1 equals to 10 seconds and TO2, which is 9 seconds. Now we want to find the least common multiply between these two numbers. Okay, so the first step that you need to do is to find the prime factor. Find the prime factor of each number. Okay. Okay. So you have here what? Number 6 and number 9. So 6, if you decompose it to its prime factor, is actually 2 multiplied by 3. Okay, while number 9, okay, the prime factor is actually 3 times 3. Okay, 2 and 3 are prime numbers. Okay, you cannot divide them to make it a smaller number. Okay, so they are the prime factors. The step 2, you need to find the occurrence of each prime factor. Okay, so in this case you have a prime factor of number 2 and number 3. Okay, so you want to find the occurrence. Okay, so here if you look here, number 2 occur only here and occur only one time. Okay, so for number 2 the maximum occurrence is 1. Now number 3, it occurs here one time, but also occur here at number 9, okay, 2 times. Okay, so for number 3 or prime factor 3, the maximum occurrence is 2. Okay, then step 3, you want to multiply, okay, all prime factors. However, it is not simply multiplication. Okay, so this is how you multiply them. 2 to the power of 1 multiply by 3 to the power of 2. Okay, so and this one is 2 multiplied by 9, so you get 18. Okay, so this 18 here, okay, is your TO, okay, which is the period of GT. Okay. Now once you get TO, you can find FO, right, which is 1 over TO, so it's 1 over 18 Hertz, right? So now this example is easy because these two numbers, TO1 and TO2, are integer. So if you have a non-integer number, okay, for example, let's say you have 3 numbers like this. Let's say TO1 equals to 2 over pi, and then you have TO2 equals to 3 over 2 pi, and you have TO3 equals to 5 over 7 pi. Okay, now you want to find the LCM, least common multiply, of these 3 numbers, and they are not integer number. Okay, so there is additional step that you have to do in order to find the LCM of these 3 numbers. So step 1, you have to make all numbers integer first, okay, and integer. So how can you do this? You can do this by multiplying all these 3 numbers with a common number. Okay, for example, TO1, 2 over pi. If you multiply it with 14 pi, you will get 48. 28. Okay, for TO2, 3 over 2 pi, if you multiply it with 14 pi, you will get 21. While TO3, which is 5 over 7 pi, if you multiply it with 14 pi, you will get 10. Okay. So now you have made all numbers, all TO1 an integer, TO2 an integer, and also TO3 an integer. Only then can you find the prime factor of each numbers. Okay, so you have what, 28, 21 and 10. Right, so 28 is 4 by 7. Okay, you can write 4 by 7, but 4 is not a prime number, so it's equal to 2 times 2 times 7. Okay, now all are prime numbers. 2 and 7, they're all prime numbers. 21 is 3 by 7. 3 and 7 are prime numbers. While 10, 2 times 5 will give you 10. 2 and 5 are prime numbers. Okay. Then the next step is step 3, find occurrence of each prime factor. Okay. So what number you have? You have number 2, you have number 3, you have number 5, and you have number 7. Now if you look here, number 2 occur here 2 times, while number 2 occur here 1 times. So to say the biggest occurrence or the maximum occurrence of number 2 is 2. Now number 3. Number 3 occurs here and 1 time. Right? So 3, the number of occurrence is 1. Number 5 occurs here and 1 time. Okay, so for number 5, occurrence is 1. Now number 7 occurs here 1 time and also occurs here again 1 time. Okay, so for 7, maximum occurrence is 1. Okay, now you go to step number 4. Let me put it here. Okay, step 4, multiply prime factor. Okay, so you will have, but like I said before, it's not simply multiplication. Instead, it will be the prime factor to its to the power of its occurrence. Okay, so in this case, 2 to the power of 2 multiplied by 3 to the power of 1 multiplied by 5 to the power of 1 multiplied by 7 to the power of 1. So here you will get, I think, 420. Okay, but however, this number is not yet your fundamental period. Okay, because remember in step 1 you multiply each number with 14 pi. Okay, so the next step will be divide with 14 pi. Okay, in order for you to get TO. Right, so now TO, okay, is 420 divided by 14 pi. So you get 30 over pi. So this is your fundamental period, okay, which is the period of a signal that is the result of adding 3 signals with this fundamental period. Okay, so I hope this one clear, okay, on how to apply least common multiply to find the fundamental period. Okay, now let's have a look at the third example, or the third problem, which is this equation. Now again, you can see that GT is the result of summing a sine function and a cosine function. Okay, so in this case we have G1 of t again and G2 of t, and this equation is actually very similar to the third equation, except that for the cosine function we don't have pi over here. Okay, so again, let's solve this one function at a time. So G1t is 10 sine 12 pi t. Okay, so if you write the general function of a sine, it's S sine 2 pi f naught t. Okay, so you will have 2 pi FO equals to 12 pi. Now FO equals to 12 pi over 2 pi. So FO equals to 6 Hertz. Then the period, okay, let's call this TO1, and let's call this FO1 as well, will give you 1/6 second. For G2 of t, you have 4 cos 18t. Okay, again you write the general function A cosine 2 pi FO t. Okay, so 2 pi FO, let's call this FO2, equals to 18t. Sorry, don't need to write the t, just 18. Okay, FO2 equals to 18 over 2 pi. So FO2 you will get 9 over pi. Okay, so TO2 you will get pi over 9 seconds. Okay, so if you look at the number here, okay, you have two numbers. So like I said before, in order for you to find TO, you need to apply the least common multiply, okay, of TO1 and TO2. Okay. And so if you look at these two numbers, if you analyze these two numbers, you have a non-integer 1/6 and pi over 9. And again, if you look at this one, here you have pi, right? So, but here you don't have pi. So it means you cannot find a single number that can be used to multiply these two numbers in order to make them integer. Okay, because let's say if you multiply this with let's say 9 pi, so you get 1 second. Okay, let's say you multiply this with 9 pi, not 9 pi, you multiply this with 9 over pi. Okay, so you will get, let's say 1. You cannot use this to multiply with this number because it cannot eliminate pi. So for this question, since you cannot find the LCM of this TO1 and TO2, this means that GT is a periodic number or periodic signal. Okay, so even though GT is the result of summing two periodic signal, sine is periodic, cos is periodic, okay, but GT is not a periodic signal. Okay, so that's all for this video. I hope it is clear on how to determine the fundamental period and fundamental frequency of periodic signal. Okay, so I will see you in the next